Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Core Mathematics paper 0580 stroke 12 for May June 2025, and this is part 1 for questions 1 to 15. Question 1, write the number 16,062 in figures. So you have 16,000, then 62. You can add on this like this, and then what do you get? You have a 62 here, then a 0, and then a 16 here. So that is going to be our answer. So I just get this one here, then I shift it, I put it here as my answer. Question 2, write 3/4 as a decimal. You know, a quarter is 1/4. Okay, so 3/4, you get this times that. Okay, so as a decimal. Now we shall have a quarter is 0.25. So if there are 3 of them, then we have another 0.25 and then another one. So when you add all of those, we can even just say 0.25 then times 3. Okay, so when we multiply 3 times 5, we get a 15, not so? Take one here. 3 times 2, 6 plus 1, 7. And then 3 times 0, that is 0. So we have 0.75. And then percentage. So we shall have this 3/4, then we multiply it by 100. Or you can get this 0.75 you have gotten times 100. So already 4 goes into 125 times. So that means this one will be 75%. Question 3, write down the value of root of 36. Root of 36 is of course 6, because this one is 36 is 6 squared. So I can have 6 squared then to the power of a half, because square root means power half. Now using the rules of indices, these two will multiply. So you have 2 times a half, and then you get 6 power 1. So that means your answer is 6. And then 10 cubed is going to be 10 times 10 times 10. And this one will give us what? 1,000. And then question 4. The diagram shows the line AB and a point P. Then they are saying measure the length of the line AB in millimeters. So just get your ruler and then you measure. Okay. Since you all do the same paper with those same measurements, so when you measure this one here, you must all get the same answer. Okay. However, when you just put this paper, when you print it out, because there is an option for fitting the paper to the printer margins, okay, you are not going to get the same, because if you fit the paper to the printer margins, what is going to come out, there is going to be an enlargement scale factor, you see. So the lengths that are going to come out, they are going to reduce by a certain value, but the angles in such, the angles remain the same. So we call it similarity of figures. So you get what we call similarity of figures. Now, using this software that I have, you know that these divisions in here, they represent millimeters. So this is a centimeter, but it has how many divisions? They are 10. Okay, so those are 10 millimeters. So here I'm seeing this one is approximately what? 8.5 centimeters. So if it is 8.5 centimeters, then that will be 85 what? Millimeters. Okay, so based on what I've measured here, I'll put 85 millimeters. 85 millimeters. But in the scheme, when you are doing this, you are going to get your answer as 83 millimeters. Okay, because you all do the same paper. You see that? So if you all do the same paper with the same measurements and everything, you must get that answer as 83 what? Millimeters. So go with what you measure. Okay. Then part B, draw a line through point P that is perpendicular to the line AB. You can use a protractor to measure 90 degrees at P. Okay. You can use your compass, but they didn't tell us to construct. If they had told us to construct, then we would do what? We would do so. But you just get a protractor, and then after that, you just put it at point P here. Make sure you balance with this line here, AB, and then after that, so where you are seeing, they said draw a line through point P, through, so it should pass through point P like that. Okay, so I'm going to mark this point here 90. Let's say I'll mark just a small point there, and then I can remove this one here. Then I can draw just like that. So, and then I can put on that marking to show that it is 90 degrees. If you want, you can use the compass. So you put your compass pointer here at P, you make an arc here and then here. Then after, you can, let me even show it to you right away. You can get your compass. We can put it on point P, but they never said we construct, but this one produces a perfect what? A perfect diagram. So you have to make an arc here. Okay, then you also come this other side, you make an arc, but now you see, based on my compass here, it goes beyond the B. Now you can stretch your compass the way you want. Then you put your compass pointer where this arc cut this line here, okay, of AB. Then after that, we can now stretch. I can even maybe reduce it a little bit. Then you draw an arc up. You also come down here. You draw an arc like that. And without tampering with the length of your compass, now we can put it this other side. And then we also draw an arc. Then we also come this other side and we draw that arc. So you see the line that I've drawn. Then you connect where those arcs are made. See, it's almost there. So the problem I've gotten here is because I did what? I drew an arc that goes beyond this line. So trying to balance this becomes like it. But you just use your compass and you draw the what? I mean, you just used the protractor. You put it here at the middle of the midpoint of your protractor. You put it at P, and then you measure the 90 degrees. Then you draw a line all through. They just said draw. Okay, so you don't need to waste time constructing. Is that clear? Okay, so that is that. Question 5, complete this statement. 10 weeks is dash days. We know that 1 week, okay, 1 week is equal to 7 days. So that means 10 weeks is equivalent to 7 times 10. which is going to be 71 days. Then question 6, shade 2 out of 5 of the rectangle. So 2 out of 5, first of all, I'll get the squares. How many are we seeing here? 1, 2, 3, 4, 5, 6, 7, plus 7 here, plus 7, plus 7, plus 7. So 7 times how many? 7 times 5? Yes. This is 1, 2, 3, 4, 5. That is 35, not so? So I would say 2 out of 5, then times 35. So 5 goes here 7 times, and this one will give us what? 14. So we have to shade 14 squares. Okay, that is that. Now we are going to shade these 14. You shade the ones that you want, whichever you want. So 14, since these ones are 7 and also these ones are 7, so I'm going to shade those two. Okay, so just like that, you can shade them completely, or you can just use those lines like the way I've done it. As simple as that. Then question 7 part A, find the value of the reciprocal of a third. So here we need to somersault. The 3 goes up and then the 1 down. So that means we are going to have a 3. You don't need to write 3 over 1. Just write 3, okay? Part B, write 2 to the power of negative 3 as a fraction. So using the rules of indices, 2 to the power of negative 3 is the same as saying 1 over 2 to the power of 3. So the power here becomes a positive when you take it down, okay? Then from there, 2 times 2 times 2, that is the same as 1 over 8. So that is going to be our answer. And then question 8, put one pair of brackets into each calculation to make it correct. So this is negative what? 16. And to get that negative 16, if it's a pair of brackets, I can put it here. I can even enclose 3 numbers, you know. Okay. Now, suppose I begin from, let's say, this side, and I say like this. This implies that I'm going to have 12, then plus 4. And remember, when we are doing this, we are using what? BODMAS. Okay. 12 plus 4, then divide by, this one is going to be a negative 1. Not so? Now, division here comes before what? This comes before the plus. So that means we are going now to have, this is 12, then plus, what do we get here? Now 4 divided by negative 1, you get negative 4, not so? So if you get negative 4, then we shall have negative 12, then minus 4, which will equal to negative 16. So that means our pair of brackets is supposed to be there. And then the other one is going to be here. I'll put the pair right here, because if I do so, inside here, I'm going to have, first of all, we have negative 3, then minus 4 plus 5, that will be a 9, minus 2. 9 minus 7, you get minus 2. You see that? And then minus 3 minus 2, you'll get minus what? 5. So the pair has to be there. This one has enclosed how many? 5. 3 numbers in there. So this is minus 3. This one must give me minus 2 for me to get minus what? 5. As simple as that. Then question 9, we are supposed to write these fractions in order, starting with the smallest. Now, how to do this one here? We are going to get equivalent fractions, okay? Convert to equivalent fractions with the same denominator. y with the same denominator, then you can easily see the numerators, which one is bigger than the other, and then you arrange. Okay, so this one here, we have 8, we have 12, we have 3, we have 4, we have 24. All of them, the LCM is 24. 12 can go into 24, 3 can go into 24, 4 can go into 24, 8 can go into 24. So I can have 5 over 8, then times 3, then this one gives me 15 out of what? 24. Then I have 11 out of 12. 12 times 2, that is how we get the 24. So I will also do it up. So it's like I've done nothing, because this operation can easily cancel with the one down. You see that? Then 2 out of 3, this one has to be times 8, then even here. So I will have 16 out of 24. And then what else? We shall have 3 over 4. 3 over 4. So here I have to multiply by 6. So 3 times 6, that is 18 out of 24. Now, meaning I'm going now to have 15 out of 24. This 11 over 12 is 22 out of 24. This 2 over 3 is 16 out of 24. The 3 over 4 is going to be 18 out of 24. Then this one is 13 out of 24. Now what you're going to do is to just now compare the numerators. So the smallest is going to be 13, okay? So this one is going to be 1. Then the next one is going to be 15, so this is 2. Then the third one is going to be the 16 here. The fourth one will be the 18, and then the fifth one will be the 22. But when you are arranging them, you don't write these numbers you have gotten. Use these ones here, okay? So the first one is 13 out of 24, okay? Then we have the second one is 15 out of 24, but it corresponds to 5 out of 8. 5 out of 8. And then the next one is 16 out of 24, which corresponds to 2/3. So 2 out of 3. Then the next one, the fourth one, is 18 out of 24, which corresponds to 3/4. So 3 out of 4. And then lastly, we have 22 out of 24, which corresponds to 11 out of 12. So that is that. Question 10. A cuboid has length 5 centimeters, width 2 centimeters, and height 3 centimeters. But draw the net of the cuboid on 1 centimeter grid. Now in here, the cuboid, we have the length here, which is 5. Then the width is 2. Then when I try to put it all together, that is the one here. So the height is 3. If the height is 3, then this implies, let me first put this one here. I can cut here, okay? Cut here, then cut here. Then this one folds off this way. You get it? Then cut here, and cut here, and maybe cut here. Then we cut here. This one falls off this way, then this one we can take it there. This one will fall off this other side. You get it? So this implies that we are going to have something like this. 5, there is this one 5 by 2. Okay, so I will come here and I put 5 by 2. Let me leave one up there. 5. These are 5 boxes there, and then by 2, this is the one here. So then after that, because let me just get this one, I duplicate it, put it here, you see. And then from there, I will get this one here, also duplicate it, put it here. Then after that, now that is our base, not so? The one at the bottom. Now, when we open this one here and it folds this way, we are going to have this face here in the sides falling this way. So it will go 3 units. When it falls off this way, this will be the 3 units. Okay. Now that means I'll go 3 units here. Okay. And after that, those 3 units, they are the same that we shall put this other side here. Okay. Of course, this one, I'll continue it down because it is giving us a full face. You see, it is 3 by 2, so I'll duplicate this one, put it here, and also this other side. Then, of course, this one here, duplicate it and put it here. Then, after that, what else are we going to have? Now, this face here, there is this one now that is going to follow this way, which is 5 by 3. Okay. This one facing us, so 5 by 3. Remember, this one here, which is 3 units, has to be the same as this one here. You get it? So we have something like this, such that this one here, if it is the same as this, when you fold them up, they are going to fit on each other. You see that? So I'll have 3 units here, but let me first duplicate this one here, then put it right here. Then after that, remember, this one has to be 3 units, so just connect this to that. And then after this one, the same thing that we do, so I'm going to just duplicate this one here, we put it there. And then now these are two faces that are the same, just like this face here is the same as this one here, so you have it here and here. Are we there? Then this one facing us here is the one that I've drawn here. You're following? Good. Now this one that is down is our base that is here. Now since I've drawn this one here, now there is this face up here, okay, which is the same as the one down, so it is the one that is supposed to come here. You see that? So in other words, if you have this one, jump a face, then put another. Then this one that you have here, jump one here and then put it down. As simple as that. So I'm going to continue with this one here, but we need 2 centimeters down. So I will just get this one here, then duplicate it, bring it down here, then also duplicate it, put this one here, and then now produce this other one down here. Okay. Also here, just like that. And then what else are we going to do? Of course, to close this one here, then get this one and close it. So that is exactly what we are supposed to have. Oh, I didn't remove this one here. It's going to make my work ugly. So that is what you're supposed to have. Okay. And we can put this one here we can shift these ones and we put them maybe here, or we can leave them there, so wherever you want. So that is going to be our diagram there. Then part B, work out the volume of the cuboid, give the units of your answer. Volume of a prism, but this time around it is a cuboid. We get the cross-sectional area, then times the what? The length. So when I cut this one like this, I keep on cutting, I'll be seeing this face, which is rectangular. Okay, so the cross-sectional area is the rectangular face, then times this height here. So the area of a rectangle, we know that it is length times width, but then we have this height here. So we have the length is 5 times the width is 2, then times the height, which is 3. So this will be 10 times 3, that will be 30. Okay, so if we get that 30 and we write it here, then the units, you are having a centimeter times a centimeter times a centimeter, which gives us centimeters cubed. Okay, that is that. Question 11, 0, 2, 2, 3, 4, 7 is a list of 6 numbers. Write down the mode. Mode is the most appearing number. Okay, most appearing number. And when you look at that list, we can see that 2 is appearing 2 times and the rest are appearing once. So that means the mode is going to be a 2. Then work out the range. The range, we always get the highest value, okay? And then we subtract the lowest value. So biggest value minus the smallest. So the biggest value is a 7, the smallest is a 0. So you will get your range as 7. Then work out the median. You are going to arrange these numbers in order, and they are already in order. Then we cancel from the extremes. Okay, so we cancel this and this, this and this. Then the ones that remain in the middle, we get their what? Average. So median is going to be equal to 2 plus 3 out of 2, and this one will give us 2.15. Then mean is equal to sum of all the numbers, then divide by how many they are. So we have a 0, then plus 2, then plus 3, then plus 4, then plus 7, and then we divide by their 6. So what do we get here? This one is a 4, then plus 3, that will be a 7, then 11, then plus 7, that will be 18. So 18 out of 6, of course this one gives us a what? A 3. So that is that. Then question 12, they are giving us a method to use here. They are saying Tim has a method for multiplying a number by 99. He shows his method for 53 times 99. So 53 times 99 is equal to, you get 53 times 100. So it's like you're having 53, 99 of them. You get it? But if you're having 99 of them, that means you can have 153s, then minus 153, because 100 minus 1, you get what? A 99. So that's why they are saying 53 times 100, then minus 153. You see that? Because if I factorize out this one, it will be 53 into, here I have 100, then minus, of course, here there is a silent times 1. So we shall have minus 1. That is how it comes to be this 99 inside here. You see that? Then here it becomes very easy to compute. So you have 53 times 100, which is 5,300, and then minus the 53. Then when you subtract, you get this, right? So if it is 85 and we are supposed to use 85 times 99 and we are supposed to use this method, I will say this is 85, then times 100, then minus 85. So this one is going to be 8500, then minus 85. Okay. And then from there you can subtract the way you want. This is 0 and 0. Now When I borrow 1 from here, I'll remain with the 4. Then put the 1 here. When I put the 1 on this 0, it becomes a 10. But then I have to borrow 1 from there. That means what remains will be a 9. Then I take the 1 here. Now you have 10 minus 5, you get a 5, right? And then 9 minus 1, minus 8, you get 15. Then here, of course, we have 4 minus 0, which is a 4, and then 8 minus 0, that is 8. So our answer is going to be 8, 4, 1, 5. In other words, you would ask yourself, what should I, if this is 500 minus 85, oh, you get 100 minus 85, what do you get? You get 15. So that means you have only 15 to make 500. So you put it on the 400. So that is 401 and 15, which you are going to get there. Question 13 is coming from symmetry part A. A quadrilateral has geometrical properties for equal side length. So for equal side lengths, we are going to have, this one can be a square or a rhombus. Square or a rhombus. Then 2 lines of symmetry, then that has to be a rhombus. Okay, that has to be a rhombus because a square has 4. A square has this one here. It's a line of symmetry. It has this one here. Then it has this one here. And it also has this one here. It has 4 lines. But for the rhombus, it has this one here. And it also has this one here. There are 2 lines. Order of rotational symmetry. This is the number of times a shape remains the same as it is being rotated through 361 degrees. Okay, so in this case, of course, this one is going to give us 4. If a polygon has gotten 4, if a polygon is n-sided, okay, it is a regular polygon. That means all the sides are equal. Then it is going to have number of lines of symmetry. They are going to be equal to n, and also rotational symmetry. The order of rotational symmetry is also going to be equal to that n. Okay, so for the square, it will have order of rotational symmetry 4. Okay, so the rhombus here has to be the one with those properties. Okay, then part B, write down 2 geometrical properties of a rectangle. 2 geometrical properties of a rectangle. Order of rotational symmetry. Let's begin from there. Order. It has, let me just write it as the way it was given here. Rotational symmetry. It has rotational symmetry of order 2, because when you get a rectangle and then you rotate it 180 degrees, that is when it can look the same, and then again another 180 degrees, that is when it is going to be the same. But when you rotate 90 degrees, it is going to be like this. It is not the same way like it started. You see that? So after 180, you see a rectangle coming up. Okay, then also in a rectangle, if I can talk about diagonals, these diagonals actually bisect each other. Okay, the diagonals bisect each other. So meaning this one has to be equal to that, then this one is equal to that. So that's another property. So diagonals, the diagonals bisect each other. Bisect each other. And they don't meet at 90 degrees. But this one actually might be another property. But let me just add it. But they don't meet at 90 degrees. But the diagonals in here for the square, for them they meet at 90 degrees. Okay, even the ones for the rhombus, they meet at 90 what? Degrees. You see that? Okay, let's go to C. They are saying the parallel sides of a trapezium have lengths 6 centimeters and 4 centimeters. The area of the trapezium is 15 centimeters squared. On 1 centimeter squared grid, draw the trapezium with these lengths and area. Okay, now what I need to do, first of all, we need the height. Area of trapezium is equal to a half h into a plus b. Okay, so if it is a half into a half of h into a plus b, actually if I have this trapezium here, just assuming we have that one there, then also this one here, this is our a, this is our b, then this has to be the h. Okay, so this whole diagram here, okay, if I get this whole diagram and I duplicate it, okay, then I put it, let's say here, and then we rotate this one like this to, let's say, 180 degrees. Okay, then we shift it and put it here, something like that. You're going to produce another one. The whole of it here is going to be a rectangle, not so, whose length is a plus b. Do you see that? A plus b, and then we have the width is h. So if it is length times width and the length is now a plus b, then times the width, which is h, that is the area here of that rectangle, but this one has 2 trapezia. Okay, so that means area of one trapezium is going to be a half of this area you have gotten. That is how it comes to be a half h into a plus what? A plus b. Is that clear? So that is that. In fact, I'm just going to maybe make this one, this is an h, then this is a, and then that is b. Now, area of the trapezium is given as 15, which is equal to a half. We don't know h, okay, but we have the sides here. One is 4, the other one is 6. So we have 15, which is equal to, this one is going to be 10, then divide by 2, you get a 5. So meaning h is going to be 15 over 5, and h becomes what? 3. So we needed the height. Now I can come to this one here and I draw my, I can take this one to be the 4, that is the 4, and then we need the 3 here, the height, and then the 6. This is 4, then 6, just like that. Then I can connect this one to that. So just that is it. This is 4 centimeters, this is 6 centimeters, and this one has to be 3 centimeters. You see that? Okay, so that is that. Question 14 is coming from graphs part A. Complete the table of values for y is equal to x plus 3, then times x minus 2. So you just substitute wherever there is x, you put the what? I will put the negative 3. So when I put negative 3 here, this one becomes a 0. So the whole thing becomes a 0, right? So here we'll have a 0. And then next, we shall have negative 1 here. So when I put negative 1, then plus the 3, I'll get a positive 2. Then a positive 2 times, if I put negative 1 here, so this one will be negative 3. So positive 2 times negative 3, that one will give us a negative 6, not so? Negative 6. Then when I put 0, this one disappears, and also this one. Then 3 times negative 2 you also get a negative 6. Okay, so we shall put here negative 6, then put 2. When I put 2 here plus 3, that will be a 5. Then 2 minus 2, what do you get here? Isn't that a 0? So 5 times 0, automatically you will get what? A 0. So here we shall have a 0, then put 3, 3 plus 3, that one will give us 6, then times 3 minus 2, that is a 1. So 6 times 1, that one gives us a what? A 6. So that means here we shall have 6 here. Okay, now we can plot on this grid here, that is part B. So we have negative 4 and 6. So negative 4 and 6, it is actually here. You can use the two types of plots. The one that is easier for you is what you take. So I can use the dot and then a circle. Then you can use the cross. But I prefer the dot and the circle. It looks much more clean. But you make sure that when you are drawing that circle, okay, you don't, if you put, let's say, the dot here, when you are drawing the circle, don't make it like reach this other side. Let it just be in the middle there, like maybe like that. You see that? Now when I try to take it back, do you see the plot becomes very small, just like this, and it is very, very good that way. You don't need to put something so big. Okay, all right, next we have negative 3 and 0. So negative 3, 0, it has to be on this x-axis. Next we have negative 2, negative 4, which is here. Then the next one has to be negative 1, negative 6. So negative 1, negative 6, which is just down here. Then we also have 0, negative 6, 0, negative 6. Then the next one is 1, negative 4, which is a symmetrical graph. And then we also have 2 and then 0. 2 and 0 is here on x-axis. And lastly, we have 3 and 6, which is here. Now we are supposed to join all of these points to produce a smooth curve. But before you join, now you can see that these 2 points here, we can see they are the ones down here. So when you are joining here, you don't draw a line like this and then you go like that. No, it has to curve through, because now the lowest point, or what we call the turning point, has to be in between here. And since this one here, we can see the lowest points, not actually the lowest points, but based on our graph here, the U shape, you can see it is symmetrical. 1 here and negative 2, they have the same y coordinate. 2 here and the negative 3, they have the same y coordinate, just like this one here and this one here, same y coordinate. Okay, even these ones have the same y coordinate. So the line of symmetry is that line which is going to cut the curve into 2 equal parts. So it has to pass through these 2 points that look to be the lowest. Okay, so it has to be here, so that when you draw this like that, it is the one that divides it into 2 equal parts. So that means the line of symmetry here, the turning point, or what we call the lowest point, has to be on this one, on this line here. So I can get a small point just down here, and then when I'm drawing, okay, when I'm drawing, maybe I go like that. You see that? But you don't draw this. Okay, now you join using your free hand. Okay, this one produced is a U-shaped curve. Okay, it is a U-shaped curve because when you open the brackets here, you're going to get x squared 3 plus negative 2, you get a positive 1. So x and then 3 times negative 2, that's a negative 6. So you are having this one here. The coefficient of x squared is positive. If the coefficient of x squared is positive, then you are going to produce a U-shaped curve. If it were negative, then we would have had a what? An N-shaped curve. Now let's connect these points here, and then we produce our smooth curve. So your smooth curve has to look like that, okay? But see, write down the coordinates of the lowest point. So the coordinates of the lowest point, first of all, the x coordinate has to be this one here. This has to be the line of symmetry. This is x, which is equal to, you just get the average of these two x coordinates, -1 and 0. So the average is going to be what? -1 plus 0, of course, that is 0, then divide by 2, -0.15. You see that? So I should have -0.5 here. Then the value that you are going to have here, they are going to give you a range, okay? The range is actually given as -6.6, then less than or equal to a value you're going to put there, less than or equal to, let me put a y coordinate, less than -6. Now, what do they mean here? What they mean is that the value has to be beyond this one here. Beyond the negative what? The -6, okay? And it shouldn't exceed 6.6, -6.6, because this will be 6.2, -6.4, -6.6. So you cannot go beyond this one, and like it will be so big, okay? We can also use differentiation. Well, this one is done in extended to get what we call the turning points, or we can also use completing squares. You see that? So based on mine here, I can see it just here. Let me just zoom a little bit. So I can see that what I'm having here, this is -6.2, and then maybe this is 6.4, so 6.3 will be in the middle there. Maybe this is 6.25, something like that. 6.2 something. So I'm going to write 6.25. 6.25, and by the way, it's a negative. So your answer has to be falling within this range. So whichever value you're going to put here, if it is within this range and they check your graph and they see that indeed it estimates to that value you have put there, then they give you the mark. Okay, write down the equation of the line of symmetry. We have already seen that it is x, which is equal to -0.15, and the equation of line of symmetry, equation of line of symmetry is given by this equation. X is equal to -b out of 2a. Okay, when you are solving quadratic equations using x is equal to minus b, the quadratic formula, -b plus or minus the root of b squared minus 4ac out of 2a. Okay, so at the turning point, okay, we are seeing only one value of y, just like you can check here, one value of y here for one value of x. So at that point, if I can actually extend this one and I shift it up here, and then it, let's say, passes on this x-axis here, then I'm going to get only one root, okay, one value here. So for that one root, that means that the x squared, this curve here is now, I mean the x-axis is a tangent to this curve, so it is going to cut the x-axis at only one point. You see that? So for that case, the b squared minus 4ac is going to be equal to 0, because you are getting one value from there. So this one will then go away, the whole of it, and then we remain with that b square, I mean minus b out of the 2a. That is the repeated root. You see that if you have a question like maybe x squared minus 4x then plus 4, which is equal to 0, when you solve this one, actually this one is the same as x minus 2 squared, which is equal to 0. You are going to get one value of x. Okay, this one is the same as, again, x is equal to, it is one repeated value. Do you see that? Because it is one repeated value, then that means the b squared here minus 4ac is equal to 0. Let's check it out. Our a is the one that is here, the coefficient of x squared, the b is here, and then the c is here, right? So b squared minus 4ac is going to be equal to, what is our b? Negative, it is negative 4. So we square it, then minus 4 times our a is 1, and then our c is a 4. Here you will get a 16 minus 16. Do you see that you get 0? That means when you are substituting in here, this whole thing disappears, and then you are going to get one value, minus b, which is a minus 4 here, then divide by 2a, then 2 times 1. So do you see that you are getting 4 over 2, which is actually 2, this repeated root here, the one that I told you that we get here. So that is that. So for any quadratic equation, the equation of line of symmetry, you should know that it is given by this minus b out of what? 2a. Are we there? So even when I substitute in that equation which we were given, remember when this one is expanded, we are having x squared then plus x then minus what? 6. Okay, so my a is 1, my b is also 1. So I'll have minus b is a 1, a is a 1. So don't you have x is equal to negative I have here, which is this one? So that is that. Then use your graph to solve this equation here. This is our y. So I will replace it with a y, which is equal to what? 3. Then I will go to my graph and I draw this line. Y is equal to what? 3. So draw a line. Y is equal to 3. Then where it intersects with the curve, where it intersects the curve becomes the solution. The solution. Okay, so that is what we are supposed to do. So we go back here and then we draw the line y is equal to what? 3. So y is equal to 3 is here. You just draw all through like that. You even label it. You say y is equal to what? 3. Then where it intersects with the curve, you read off that x coordinate here. Okay, and also here you do the same right here. Okay, just like that. But I think this one I never drew it well, but based on what I've gotten here, it is exactly in the middle of negative 3 and negative 4. Then even this one has to be exactly in the middle of what? In the middle of 2 and 3. Okay, I can see that here I tried to, like, it wasn't so perfect here, you see. So, and when you do that, you make this line, this one here dotted, such that it doesn't interfere with the graph that you drew before. Okay, so I have negative 3.5 and then 2.5. Okay, negative 3.5 and then 2.5. Now, since we are not all going to draw the same smooth curve, they are going to give you a range within which your values must lie. Okay, so for this case, here they give you the range of values. It is the range of values here, it is negative 3.6, then to negative 3.4. So it shouldn't go beyond this. And then here you have 2.4 to 2.6. So mine is 2.5 here, which falls in there, and also negative 3.5 falls within here. Okay, so that is that. Then question 15, Beth thinks of a positive number n. She squares the number, then subtracts 55. The number is n here. It is squared. She squares n, then subtracts 55. So we are going to have, you subtract the 55 here. The answer is 9. The answer is 9. We have formed an equation. You see that? Work out the value of n. So take this on this side. We shall have n squared, which is equal to 9, then plus 55. And this one becomes a 64, don't so? Then n is going to be the square root of this 64. Remember, it can be plus or minus. Whenever you take a square root, you have plus or minus. Then n is equal to plus or minus what? 8. But they said thinks of a positive number n. That means that number is going to be positive what? 8. You see that? So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.